Have you ever wondered how an AI can translate a really long, complex sentence without just getting lost in the middle? Well, the answer is a pretty revolutionary idea that literally taught machines how to focus. Today, we are diving deep into the attention mechanism. So let's kick things off with a huge problem that used to plague early AI. Imagine asking it to translate a chunky 25-word sentence from a Wikipedia article. The issue was, these early models would read the entire sentence, cram all of that meaning into one single compressed piece of memory, and then try to translate from that. Think about it. It's like trying to perfectly recite a long paragraph by just glancing at a single blurry photo of it. The results? Yeah, it was usually a garbled mess. Now, this fundamental flaw actually has a name. It's called the information bottleneck. The model was trying to shove a massive amount of information through this teeny tiny opening, and, a ton of important details were just getting lost along the way. You see, this is the complete opposite of how our brains work. A human translator doesn't try to memorize the whole sentence at once, right? We focus on specific chunks as we translate them. But these old models, they were stuck trying to see absolutely everything all the time. So that old process, called an encoder-decoder, it went something like this. Step 1, the machine reads the sentence. Step 2, it squishes the whole thing down into a single vector, which is basically just a list of numbers that's supposed to represent the sentence's meaning. That right there, that's the bottleneck. And then step 3, the decoder part tries to build a new sentence using only that one single overloaded piece of information. For long sentences, it was basically a recipe for disaster, a recipe for forgetting. And this brings us to the breakthrough moment. The big idea was, what if, instead of forcing the machine to have this perfect, all-encompassing memory, we just taught it how to focus, just like a person does? Okay, let's take a simple Hindi to English translation. To get the English word I, a human translator only needs to focus on one single word in the original sentence, my. For that one moment, everything else just fades into the background. And this shows you just how flexible our focus is. To produce the word going, the translator actually needs to look at two input words, ja, ra. So the key here is that our focus can shift. It can zoom in on a single word or zoom out to a whole phrase, depending on what's important right then. This quote from the research that inspired this whole explainer really says it all. The core idea is to let the model decide for itself, for each and every word it writes, which parts of the original text are the most important to look at right now. So how in the world does a machine create this selective focus for itself? Well, the trick is that it creates a brand new custom-made summary for every single word it generates. And the magic ingredient behind all this is something called attention weights. The best way to think of these is as importance scores. For every word the model is about to output, it first calculates a score for every single word in the input. A high score basically means, hey, pay a lot of attention to this word right now. And a low score means, you can pretty much ignore this for now. This totally changes the entire workflow. First, the model calculates all those attention weights for the input sentence. Then it creates a custom weighted summary that focuses only on the words with the high scores. And that summary, not the whole jumbled mess, is what the decoder gets to work with. It gets fresh, perfectly tailored context for every single word it writes. But this raises the most fascinating question of all. How does the model learn which words are important? And the answer? Well, it can be explained with a really simple analogy about riding a bike. This is probably the question that just popped into your head, right? Humans don't go through and manually tell the model which words to pay attention to for every possible translation. So where do these perfect weights come from? Who's the teacher here? And the answer is as surprising as it is brilliant. Nobody tells it. There is no teacher for attention. The model figures it all out completely by itself during training. How is that even possible? Well, the bicycle analogy from a source material explains it perfectly. The old model, that was like trying to learn to ride a bike with no handlebars. Super difficult, super unnatural. The attention mechanism is like simply adding the handlebars to the bike. You see, giving someone a bike with handlebars doesn't explicitly teach them how to ride. It just provides a much better, more natural structure for them to learn on their own. Attention is simply what's called a better modeling choice. And this idea, giving a model a better structure to learn with, is a cornerstone of modern AI. Instead of trying to write every single rule by hand, you create a better environment for discovery, and the results? They're just exponentially more powerful. Okay, this all sounds great in theory, but how do we know it's actually working? How can we be sure the model is genuinely learning to focus in a meaningful way? Well, it turns out we can actually peek inside its mind and see for ourselves. What we can do is take all those attention weights the model is calculating and plot them out as a heat map. And this visualization shows us exactly which input words the model looked at when it was producing each of its output words. So when we visualize this for translation between two languages that have a similar word order, like English and French, something incredible happens. A strong, clear, diagonal line appears. This shows us that to produce the first French word, the model focused on the first English word. For the second French word, it looked at the second English word, and so on, all the way down. This is not a coincidence. This beautiful diagonal pattern is proof. It is the model showing us, plain as day, that it has independently discovered the alignment between words in two completely different languages. It learned all those connections entirely on its own. All right, let's quickly recap that journey. We started with the information bottleneck problem, where AI really struggled with a bad memory. The solution was to mimic human selective focus. This was done using attention weights, a skill the model learned all by itself because it was simply a better modeling choice. Remember the handlebars on the bike? And finally, we saw the visual proof in those heat maps that it really truly works. The attention mechanism was a massive, massive leap forward. It's the foundation for so many of the incredible AI models we see today, like Transformers and GPT. And it really leaves us with a fascinating question to think about. Now that AI has learned how to focus, what other uniquely human skill will it master next?